Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an isometric 3D projection of an engineering object into which the front view face, the top view face and the right hand side view face of the solid, they have been appropriately combined into a single 3D isometric projection over here. Now using the constructional details of the object available with us through this 3D isometric projection, we are required to evaluate the front view orthographic projections, the top view orthographic projections and the right hand side view orthographic projections over here. So here we have got an engineering object which is a truncated rectangular prism which has been cut inclined to the base of the solid over here. And now we have also got 3 slots available with us into this truncated rectangular prism over here. While 2 of the slots, they happen to be perpendicular to the base of the solid, the another slot which is available at the top surface of the truncated solid, it is parallel to the base of the solid over here. Now in order to obtain the orthographic projections of the solid, we need to obtain the dimensions of the front view face, the top view face and the right hand side view face of the solid. Now when we are going to look at the solid from the front view orientation, so we observe that width of the solid happens to be equal to 45 millimeter, while the height of the solid happens to be 60 millimeter. So the dimensions of the front view face will be measuring 45 millimeter width and 60 millimeter height over here. Similarly, when we are going to look at the solid from the top view orientation, so we observe that width of the solid, it is equal to 45 millimeter, while the depth of the solid, it is equal to 60 millimeter. Therefore, the dimensions of top view face of the solid will be measuring 45 millimeter width and 60 millimeter depth of the solid. Now when we are going to look at the solid from the right hand side view orientation, so we observe that depth of the solid happens to be equal to 60 millimeter, while the height of the solid, it is also equal to 60 millimeter. So the right hand side view face of the solid will be having the dimensions 60 millimeter depth and 60 millimeter height of the solid. So with this information, let us proceed to evaluate orthographic projections of the solid. Now in order to obtain the orthographic projections of the solid, we have drawn the XY reference line. We have also drawn the X1, Y1 reference line over here, and we have also obtained a transfer line originating from the intersection of XY reference line and X1, Y1 reference line. And this transfer line, it is inclined at an angle of 45 degree with respect to the XY reference line. And we are going to use this transfer line in order to transfer distances alongside the depth of the solid from the top view orthographic projections into the right hand side view orthographic projections over here. So now we are required to obtain the orthographic projections of the solid using the first angle projection method. So the front view projections of the solid will be obtained above the XY reference line. The top view orthographic projections of the solid will be obtained below the XY reference line, and the right hand side view orthographic projections of the solid will be obtained on left hand side of the front view orthographic projections above the XY reference line. Now we know that the dimensions of the front view face of the solid, it is measuring 45 millimeter width of the solid and 60 millimeter height of the solid. Now into the front view orthographic projections, we are going to draw 2 vertical projector lines in such a way that these two vertical projector lines, they are separated by a distance of 45 millimeter, which happens to be the width of the solid. And these two vertical projector lines, we have appropriately extended them into the top view orthographic projections over here, because into the top view orthographic projections as well, we are going to require width of the solid equal to 45 millimeter. Now we also know that the height of the solid happens to be 60 millimeter. So now at a height of 60 millimeter from the XY reference line, we have obtained a horizontal projector line into the front view orthographic projections, and we have extended this horizontal projector line into the right hand side view orthographic projections as well, because into the right hand side view orthographic projections as well, we are going to require height of the solid equal to 60 millimeter. Now let us proceed to evaluate top view orthographic face of the solid. So we know that into the top view orthographic projections, width, it is equal to 45 millimeter, which we have already obtained, and now the depth of the solid equal to 60 millimeter we need to obtain into the top view projections over here. So two horizontal projector lines which are separated by a distance of 60 millimeter, which happens to be the depth of the solid. So they have been located into the top view orthographic projections, and these two horizontal projector lines, they have been transferred using this transfer line into the right hand side view orthographic projections over here. Now let us proceed to evaluate orthographic projections of this solid. Now usually whenever we have to draw the orthographic projections, we start with construction of front view orthographic projections to begin with. This is followed by construction of top view orthographic projections, and it is further followed by construction of right hand side view orthographic projections. But this is a special case problem into which few dimensions regarding these three slots, they have been provided to us, whereas there are few missing dimensions regarding these three slots as well. So let us see which are the dimensions which are available. So corresponding to this slot which is lying at the top surface of the solid, this height of the slot has been provided to us as 10 millimeter. Then this width of the slot has been provided to us as 15 millimeter. But this depth of the slot has not been provided to us, which is a missing dimension over here. Similarly, corresponding to the second slot, we know that this is the width of the slot over here, which is equal to 10 millimeter. But the height of this particular edge of the slot, it is not provided to us. Similarly, the height of this vertical edge of the slot, it has also not been provided to us over here. So these are two missing dimensions into this problem over here. Similarly, corresponding to the third slot, here we have been provided with depth of this slot as 10 millimeter. Then the width of the slot has been provided to us as 15 millimeter. But we have not been provided with information regarding height of this vertical edge of the slot over here. So in this case, we have to proceed by drawing various dimensions into the different orthographic views in order to obtain complete information regarding these three slots which are available with us into this inclined truncated rectangular prism over here. Now, as we are going to look at the subject from the front view orientation, so we can check this total width of 45 millimeter has been divided into three segments over here. So these are two flat surfaces, whereas corresponding to this rectangular slot which has been provided over here, this width is also provided to us as 15 millimeter over here. So now, having marked three segments alongside the width of the solid, each equal to 15 millimeter, now we have been able to obtain two vertical projector lines into the front view orthographic projections, and we have appropriately extended these two vertical projector lines into the top view orthographic projections over here. Now we observe that this vertical slot at the base of the solid and this horizontal slot at the top surface of the solid. So both of these slots, they are available centrally alongside the width of the solid. So now let us evaluate the center point alongside the width of the solid over here. So we have marked a distance of 22.5 millimeter from the right hand side face of the solid, and a vertical center projector line we have been able to obtain into the front view projections, and we have extended this vertical center projector line into the top view orthographic projections over here. Now next we observe that this distance of this flat surface from the top surface of the solid, it happens to be equal to 10 millimeter. So now we are going to measure a distance of 10 millimeter from the top surface of the solid, so that this segment can be located into the front view orthographic projections over here. So now at a distance of 10 millimeter from the top surface of the solid, we have obtained a horizontal projector line into the front view orthographic projections, and we have appropriately extended this horizontal projector line into the right hand side view orthographic projections over here. Now as we draw this horizontal projector line, so one thing we have evaluated over here, so the true shape of this cut rectangular surface, it has been obtained into the front view projections over here. We can check point 1, point 2, point 3 and point 4. So this is a vertical cut surface which is visible to the observer from the front side. So we can mark 4 dots over here corresponding to the location of this horizontal slot towards the central portion of the top surface of the solid over here. So this way, true shape of this cut section regarding this slot has been obtained over here. Now next we have got this vertical slot which is lying centrally at the base of the solid over here alongside the width of the solid. We know that this is the width of the slot which is equal to 15 millimeter. So this point and this point, they have already been located over here corresponding to these ends over here. So these two ends, they have been located at this point and this point. Now we know that this depth of this rectangular slot, this is a rectangular slot which has been provided over here at the base of the solid. So corresponding to this rectangular slot at the base of the solid, the depth of the slot happens to be equal to 10 millimeter. So from the front face of the solid, we are going to measure a distance of 10 millimeter, and one horizontal projector line we have obtained into the top view projections, and we have appropriately transferred this horizontal projector line using this transfer line into the right hand side view projections over here. So the moment we draw this horizontal projector line, we can check, as we are going to look from the top, this horizontal surface at the base, so this is a rectangular surface, it is parallel to the horizontal plane. So since the surface happens to be parallel to the horizontal plane, so we are going to obtain true shape projections corresponding to this slot into the top view projections over here. So 4 dots into the top view projections we have obtained corresponding to the true shape projection of this particular rectangular slot onto the horizontal plane in the top view projection. Next, corresponding to slot number 3. So this is another information which is available with us. That is, onto this inclined surface which is going to join this point with this point. Here we have got a rectangular slot which is available once again at the center of the solid alongside the depth of the solid over here. So this is the depth of the solid, and alongside this depth of the solid, this is going to be my center point. So now I know that this 10 millimeter, it is the width of this rectangular slot. Again we can check, this is a rectangular slot which has been provided into this inclined surface over here. So now we note that this dimension, that is the width of this rectangular slot, happens to be 10 millimeter. So now into the top view projections, we observe that if we mark a distance of 10 millimeter from the right hand side face of the solid, so from the right hand side face of the solid, if we measure a distance of 10 millimeter towards the left hand side face of the solid, one vertical projector line we have been able to obtain into the top view projections, and this vertical projector line we have appropriately extended it into the front view orthographic projections over here. And another information we do have, this rectangular slot, it is provided at the center of the solid. So now we can mark the center of the solid alongside the depth of the solid. So from the rear face of the solid, we have marked a distance of 30 millimeter because 60 millimeter is the total depth of the solid. So now having marked this distance of 30 millimeter from the rear face of the solid, a horizontal center projector line we have been able to obtain into the top view projections, and using this transfer line we are going to transfer the center projector line appropriately into the right hand side view projections over here. So now we know that this is our center line, but this slot is having depth is equal to 20 millimeter. So how do we obtain this rectangular projection in the top view? Here we have to take an offset of 10 millimeter above the center line towards the rear face of the solid. We have to take an offset of 10 millimeter below the center line towards the front face of the solid, and these two horizontal projector lines separated by a distance of 20 millimeter we are going to obtain into the top view orthographic projections. And using this transfer line, once again we have appropriately transferred these two horizontal projector lines into the right hand side view orthographic projections over here. Now we observe that the moment we draw these two horizontal projector lines, we have been able to obtain true shape projections corresponding to this rectangular slot which is available with us alongside the depth of the solid over here. So this is again a vertical rectangular slot which is available alongside the depth of the solid. So now we can check 4 dots we have marked over here corresponding to this base of the rectangular slot, and since this cut section, it is resting onto the horizontal plane or it is parallel to the horizontal plane, so the true shape projections corresponding to this cut section we have been able to obtain into the top view projections over here. And the last dimension which is available over here corresponding to the solid, it is equal to 10 millimeter into the front view projections over here. So now we can check as we look at the solid from the front view orientation. So therefore we observe that this height of this surface above the ground, it is equal to 10 millimeter. So now we have to mark a distance of 10 millimeter above the ground, and we will be obtaining a horizontal projector line into the front view projections, and we are required to extend this horizontal projector line from the front view projections into the right hand side view orthographic projection view over here. Now the moment we draw this horizontal projector line, now we can check automatically we have been able to obtain true shape projection of this surface of the front face of the solid. Only this surface we have been able to obtain over here. So the 4 dots we have been able to obtain corresponding to this cut section which is parallel to the vertical plane. So you can check we have been able to obtain true shape up to this point. So this surface true shape has not yet been obtained over here. Only true shape of this cut section has been obtained into the front view projections over here. And now another thing we can observe over here, as we extend this horizontal projector line into the side view projections, So this end point is going to determine the location of the height over here corresponding to this inclined surface. So this height is 10 millimeter, this height is 60 millimeter. So now we can check at the front face of the solid, the starting point of the inclined surface will be lying over here, and at a height of 60 millimeter towards the rear surface of the solid, the end point of this inclined surface will be located over here. And now we can check. Here we have been able to obtain the edge view projections corresponding to this inclined surface onto the profile plane. It means that this inclined surface happens to be perpendicular to the profile plane. So now we have drawn all the dimensions which were provided to us into this geometric construction of the solid over here. Now we need to identify few missing dimensions. What are the missing dimensions? This depth of the top surface horizontal slot is missing over here. So let us evaluate this depth of the horizontal slot. Now we know that the height of this slot, it is equal to 10 millimeter, which we have already worked out. We also know that width of the slot has been provided to us as 15 millimeter. So this 15 millimeter we have already evaluated. How do we evaluate the depth over here? Now we can check. As we had drawn a horizontal projector line through this point, because I want to determine distance of this edge from the rear face of the solid. This is the rear face of the solid. I want to measure this dimension over here. Now we can check that we can use the orthographic projections principles in order to evaluate this depth of the top surface horizontal slot over here. Now we can check, as we had drawn this horizontal projector line onto the side view projections over here. So this is the point of intersection of this inclined surface with this horizontal surface over here. So through this intersection of this inclined surface and the horizontal surface which we had obtained through these 2 points of the horizontal slot. So now what we have to do, usually what we are doing, usually we are finding out depth from the top view and then we are taking those distances into the right hand side view over here. Now from the rear surface we can check. From the rear surface we have obtained the depth of this horizontal surface into the right hand side view. So now this depth into the right hand side view will be transferred from this intersection point into the top view orthographic projections over here. So what we have to do, from this intersection point we have to take a vertical projector line into the right hand side view orthographic projections, and this vertical projector line we are required to transfer using this transfer line into the top view orthographic projections over here. So this way now we can check. We have been able to obtain 4 points over here corresponding to the top view projections of this horizontal surface onto the top view orthographic projections over here. So now we can check these 4 dots which are going to represent the rectangular true shape projections of this horizontal surface, which will be visible to the observer from the top view orientation over here. So this way one missing link, that is the depth of this horizontal slot, has been evaluated over here. Next we need to evaluate height of this point from the ground. We need to evaluate height of this point from the ground over here. So how do we evaluate these 2 points? So once again we are going to make use of fundamentals of orthographic projections in order to evaluate location of these 2 heights into the front view projections over here. We can check this edge will be visible to the observer somewhere here. This edge will be visible to the observer somewhere here. But for now, I do not have any information about the height of this horizontal edge over here or height of this edge into the front view orthographic projection. So how do I evaluate these two segments of the cut section over here into the front view orthographic projections? Now once again, we are going to combine different orthographic views over here. Please check. Here into the top view orthographic projections, we have already obtained true shape projection of the rectangular slot. Now, once we have drawn this horizontal projector line, so this horizontal projector line corresponds to this edge. So please check, this edge is closer to the rear face of the solid. This is the rear face of the solid. So now from one of the edges, which is the true shape of this rectangular slot, which is closer to the rear face of the solid, once we draw a horizontal projector line and we transfer it into the right hand side view orthographic projections, now we observe that this is the point of intersection between this inclined surface and this particular portion, which is corresponding to this rear edge, which is available with us into the top view projections over here. So we have taken this backwards, and now once we transfer it into the right hand side view, let us find out the point of intersection with the inclined surface. This is the inclined surface. So now this surface and inclined surface, wherever they intersect, from this point of intersection, now we need to draw a horizontal projector line into the right hand side view orthographic projections, and we have to extend this horizontal projector line into the front view orthographic projections over here. So this way, this top surface height from the ground has been evaluated over here. We can check, this is the top surface which has been obtained into the front view. Now this will be the height at which this surface will be visible to the observer in the front view orthographic projections. Now let us focus on this edge. So now this edge is represented over here into the top view orthographic projection. So this edge, it is closer to the front face of the solid. So this edge, it is closer to the front face of the solid. Now once we draw horizontal projector line through this edge of this rectangular slot and transfer it using this transfer line into the right hand side view orthographic projections. So this vertical projector line intersection with this inclined surface. Now we can check this vertical surface intersecting with this inclined surface. It will provide us with the location of this segment into the front view orthographic projections over here, because this total surface is perpendicular to the profile plane. So this is appearing as an edge view or a point view into the right hand side view projections over here. So through this intersection point, which is corresponding to this surface, we can check once again. So now we need to draw a horizontal projector line through this intersection point into the right hand side view projection view and extend this horizontal projector line into the front view projections over here. So now this surface having width is equal to 10 millimeter will be indicating the true length of this edge, which will be visible to the observer from the front view orientation. So now 4 dots once again we can mark over here corresponding to this vertical surface. We can see through this edge we'll be able to find out this vertical surface which is visible to the observer from the front view orientation. And again, since this vertical surface happens to be parallel to the vertical plane, so the true shape of this cut section has been obtained into the front view projections over here. So now this dimension and this dimension, both of these dimensions, that is height of this surface and height of this surface, has also been determined. Now only one unknown parameter is remaining, height of this horizontal surface we need to determine. Now in order to determine height of this surface, we know that corresponding to the vertical slot which is available towards the front face of the solid, this depth of this vertical slot happens to be 10 millimeter. So this we had already drawn over here. So once we draw this depth of 10 millimeter, these 2 points we have already identified into the top view projections over here. Now once we draw a horizontal projector line through this surface, through this edge over here from the top view projections, and we transfer it using this transfer line into the right hand side view projections over here. So this vertical projector line, wherever it intersects with this inclined surface, we can see. So this edge view will be generated over here into the right hand side view orthographic projection area. Now through this point of intersection, once again a horizontal projector line will be drawn into the right hand side view projections, and it will be extended appropriately into the front view orthographic projections over here. Now we can check this surface true shape we have identified into the front view projections over here. It is this surface which we have evaluated, because this surface we had already evaluated before. So now 2 more dots we are going to add. So this way all the elements corresponding to this solid, they have been identified and located into the 3 orthographic views: front view, top view and the side view projections over here. Now let us darken the surfaces which will be visible to the observer, as the observer is going to look at the solid from the front view orientation. Now we can check, this is the boundary of the solid which will be visible to the observer. So it is this boundary. This is the total boundary of the solid which will be visible to the observer over here from the front view orientation. Then we see that these 2 surfaces at the front face, they will be visible to the observer and they are parallel to the vertical plane. So they will be represented as true shape rectangular cross sections visible to the observer from the front view orientation. Then corresponding to this rectangular slot, so this complete rectangular slot, it will again be projected as a true shape projection over here. So this is true shape projection, this is true shape projection, this is also true shape projection, this is also true shape projection over here, and this is also true shape projection corresponding to this area over here. So this area is again projected as a true shape projection over here. And one more thing we need to observe, this inner portion of this rectangular slot below this edge over here, this will not be visible to the observer from the front view orientation. So a dotted line or a hidden line projection has to be drawn into the front view projections corresponding to this surface over here. So this surface is not visible, so this will be drawn as a dotted line into the front view projections over here. Whereas this complete surface, it is inclined with respect to the vertical plane, so we are going to obtain starting from here. So this portion, this complete portion, it is represented as apparent shape projection projected onto the vertical plane into the front view projections over here. So this complete portion will be projected as apparent shape projections over here. So this complete portion above this wall, so above this height, so this portion, it is true shape, true shape, true shape, true shape, and this one is also true shape. So rest everything above this particular edge, so this portion will be complete apparent shape front view projection which we have been able to visualize. Similarly, from the top view orientation, so this is the boundary, we can check, this is the boundary which will be visible to the observer over here from the top, right? Then corresponding to this rectangular slot, we are able to visualize true shape projection over here. So this is true shape projection corresponding to this horizontal surface, because this is parallel to the horizontal plane. This slot is also true shape. This slot is also true shape representation. And this entire inclined surface, because it is not parallel to the horizontal plane and it is inclined to the horizontal plane, the apparent shape projections, they have been obtained into the top view projections over here, corresponding to this inclined surface. Then we have got the side view. So into the side view, so this portion will be visible to the observer. So this is the boundary of the solid. Then corresponding to these two vertical edges, so we will be able to see these two vertical edges over here. So this is true shape, this is true shape, this is also true shape. So this surface is true shape, this surface is true shape, this surface is also true shape. Now we know that this surface, it is not visible to the observer, this surface. So now corresponding to this vertical face, dotted line projection will be available over here. But this projection will be once again true shape projection over here, which is obtained into the front view projection. So this is again a true shape projection corresponding to this surface over here. Next we have got this triangular surface. So this triangular surface, again it is not visible to the observer. So corresponding to this horizontal surface, dotted line projections will be available over here. And once again, this is a true shape projection corresponding to this triangular surface over here. So with this, we have been able to complete front view orthographic projections, the top view orthographic projections, and the right hand side view orthographic projections of the solid when the 3D isometric projection of the object depicting the constructional details of various elements of the solid, it had been provided to us. So this is all for today. We are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.